The topic of this video is composing functions. Let's look at a problem. In this problem, we see how composing functions can be applied in a real-world situation. The surface area S in square meters of a hot air balloon is given by S of r equals 4 pi r squared, where r is the radius of the balloon in meters. If the radius is increasing with time t in seconds, according to the formula, r of t equals 2/3 t squared, with t greater than or equal to 0, find the surface area S of the balloon as a function of the time t. Alright, so two things that I'd like to discuss with you before we begin solving this problem. The first is this element here, t is greater than or equal to 0. The reason why this is included in the problem is because t represents time, and time cannot be negative. Therefore, it has to be 0 or positive. T is greater than or equal to 0. The second thing I would like to go over with you is this diagram. This diagram represents what's happening in this problem. As time goes by, the radius of the balloon is increasing, and there's a formula that allows me to know the relationship between time and radius. You can think of that as a function. The input is time, and by following the instructions, the time gives you the radius. Similarly, there is another equation that tells us the relationship between radius and surface area. If someone gives you the radius, you can plug into this formula to get the surface area. So by composing the two functions together, we can come up with just one equation that links us directly from time all the way to surface area. And that is the goal of this problem. Okay, let's go ahead and begin. So we know that we want to express S as a function of t, which means we want to create S of r of t. Let's go ahead and do that. Okay, so S of r of t. So notice that we have a variable as our inside, and therefore we're going to work from the outside in. We start with function S, and specifically the right-hand side, but everywhere we see r, we're going to put r of t in its place. So we get 4 pi r of t squared. In this problem, we are given that r of t is equal to 2/3 t squared. So now we make a substitution, and we write 2/3 t squared in place of the r of t. And since the r of t was being squared, the 2/3 t squared needs to be squared as well. So this gives us 4 pi times, an exponent tells me how many times to multiply a base by itself. So I'll have a 2/3 t squared times a second 2/3 t squared. And I need to find a way to multiply all of these things together. Some of them are fractions, some of them are not. So let's write everything as a fraction. So 4 pi can be written as 4 pi over 1 times 2/3 times t squared, which can be written as t squared over 1 times 2/3 times t squared over 1. The rule for multiplying fractions is that you multiply across all of your numerators to get your new numerator, and you multiply across all of your denominators to get your new denominator. So let's begin. Multiplying the number part up top, 4 pi times 2 would be 8 pi, times another 2 would be 16 pi, and t squared times t squared is t to the 4th because we add the two exponents together. 2 plus 2 is 4. At the bottom, 1 times 3 times 1 times 3 times 1 is 9. So we get our final answer, 16 pi t to the 4th over 9. Or, if you prefer, you can write S of r of t equals 16 pi t to the 4th over 9. This is one formula that tells us the surface area when the only thing we put in the equation is time.